Hello everyone, myself Raj. In this presentation, I will be explaining about applications of large language models in cloud computing, which was a research paper published by those authors, and it was an empirical study using real world data. The research paper was made by studying the real world data, and it was published in IJS CST on July 2024. Introduction. Cloud computing transformed business operations, providing scalable, cost-effective solutions. Like as we can see in Amazon, there is a lot of products available, and we can list all of them, and all the users can see the same products at a time without any problem or without any lag. So this was the scalability feature of cloud computing, and LLMs such as GPT-3 enhance cloud infrastructure by enabling fast data processing. Like large language models as we use in ChatGPT, like suppose if we give a prompt, it searches entire data set and gives us the proper output, or most of the time it will be the proper uh, desired result. And traditional models struggle with growing data demands, making LLMs crucial for handling large scale data. LLMs optimize cloud management, reduce human errors, and improve efficiency. Finance and healthcare industries are integrating LLMs to transform the workflow. The main research objectives in this research paper was how do LLMs provide improved data processing within cloud systems? What are the measurable impacts on operational efficiency? How can LLMs enhance security in cloud environments? How do LLMs contribute to cost savings? Large language models overview. LLMs evolved from basic statistical models to advanced neural networks. The introduction of transformer models, example GPT-3, revolutionized data processing. GPT-3 and BERT represent the most advanced models, outperforming their predecessors in data generation and context. Like in the image, you can see that attribute and the description, like CPU utilization, percentage of CPU utilized, memory usage, like amount of memory used for processing that data, network latency, time taken for data transfer from the user to the client, from the client side to the server side, storage performance, and service provider. Integration of LLMs with cloud computing. AWS, GCP, Azure, IBM and Oracle offer computational power to train and deploy LLMs. Like these are the cloud service providers. They allow users to deploy their LLMs and use them. LLMs facilitate real-time data processing, enhanced security, and efficient resource allocation. Cloud platforms enable scalable AI development, reducing upfront infrastructure costs. Like in the image, you can see tokenization process and the accuracy. Experimental setup. Three AWS EC2 instance types, T2 and 4 C5 are used to simulate cloud operations. Like these are the versions of the cloud service provided by the AWS. Each one defines how much storage and how much request per minute can be done on that, and is it scalable vertically or horizontally. Those are defined by T2, M4, and C5. They were used to simulate cloud operations. Experiments ran over a month to assess LLM's impact on CPU, memory, network, and storage performance. Like they ran the experiment, like if suppose many users access the data at a time, will it be any problem or not? And this was assessed using CPU, memory, network, and storage performance. Continuous monitoring of CPU utilization, memory usage, network latency, and storage performance was also monitored during this process. So in this slide, you can see the CPU and memory optimization results. Like after seeing all the results, they tried to optimize the amount of storage used, or like read speed and the write speed, by modifying the data access type. And so this was the new results. AWS provided 35% CPU utilization, GCP 25%, Azure 30%, IBM the 20%, Oracle 40%. Like this, we can see IBM is the least CPU utilization. It is more efficient. Memory usage was optimized with T2 instances using 20 GB, M4 at 50 GB, and C5 at 70 GB. Like this was the storage given for the LLM's storage, how much it can store. Service providers like AWS, GCP, Azure, IBM, Oracle, like we can see the read and write speed in the graph, sorry, in the chart. Network latency and storage performance. LLMs reduced network latency, which rose from 15 milliseconds to 40 milliseconds over 6 days. AWS read speeds improved to 150 megabytes per second, write speeds at 100 Mbps. Other providers also saw significant gains. In the graph, you can see that AWS read speed is faster and the write speed is also faster compared to GCP, Azure, IBM, or Oracle. And AWS is the preferred cloud platform where many people used to host their deploy LLMs and try accessing it. So as you can see, the latency was also reduced from 40 milliseconds to 15 milliseconds within 6 days of span. Like very fastly, they have improved their architecture and where data can be accessed easily. Comparative analysis. Baseline models showed inconsistent resource management and erratic performance. So the baseline models were not that good for using and deploying LLMs, and later using the higher versions, it was efficient in processing. LLMs provided consistent resource allocation and optimization across all metrics. After using the better models, they could see a drastic improvement in CPU, memory latency, and storage optimization. LLMs reduced operational inefficiencies, leading to cost and savings and enhanced reliability. In conclusion, and for the future research, LLMs dramatically improve cloud computing performance, reducing costs, and enhancing resource utilization. Long-term effects of this are security implications, energy consumption, and the ethical impact of AI in cloud computing need further study. Thanks for watching my video. Please like it.